Movement is very important for any video game when you want your player to feel fully immersed. The reason being is that movement allows for you to get a little bit more of a feel for the video game world that you're in. Now, in VR, there's three different common ways of moving around in a world. First one is what I prefer to call as roller coaster movement. It's essentially having a set path that the player has to follow without them having any control over the path that they're going along. This isn't particularly great because players aren't able to exactly predict where it is that they're moving to in most cases, which often means that they're going to suffer from motion sickness. The second option for movement is to simply have a thumbstick that you can then use to move around, which tends to be better because then the player can predict where it is that they're moving to, which allows for them to reduce the motion sickness a little bit more. However, players that are still particularly prone to motion sickness are still going to experience motion sickness at some point in time, even if it does take them a little bit longer as opposed to roller coaster movement. The third option is the one that I think is typically going to be the best for most players, and that is teleportation. The reason that this is so much better is that you don't actually see the whole world shift around you. Rather, it's a simple fade, and then you're where you intended to be, which tends to be a little bit better and reduces motion sickness for just about anybody who uses VR. So in this video, I'm going to show you guys how to set up teleportation in VR, so that way you can have your player moving around in a world. So let's go ahead and jump right into it. Alright, so I've gone ahead and opened up, this is actually the same project from my last video. So this is, this is all still the same. So first things first, I want to go over the blueprint player. This is the blueprint player. Okay, so this is the blueprint player. So I mentioned last time, the blueprint player is already set to have teleportation working. It's just missing one component that's preventing it from working. The component that you're missing is, let me go and find it here. Nav, measure balance volume. There we go. So, in case you're unaware, the way this works is you want for this to cover all the floor that you want your player to be able to teleport to. So in this case, I'm actually just gonna set it to cover the whole thing. I think if I set to like 20, that's more than enough. Set to scale 20. There we go. Now, if you go ahead, this should have automatically updated. It did. So what I did is I pressed P on the keyboard. You should also be able to see this if you go into, where is it? There's supposed to be a way. You can, oh, here we go, show. And you want navigation. So everything that's green are areas, so everything that is green that you can see here, these are all places that you can teleport to. So if I actually just go and save that and play, I'm going to grab my headset here. Oh, I forgot to set the default player. Possess, receive. All right, there we go. Come on. Oh, my headset's bugging out on me. There we go. So if I go ahead and press down the thumbstick, you can actually see I'm able to teleport. And it's also set so you can rotate the thumbstick too while you're pressing it down. It doesn't work really well for the Oculus. I think it might work a little bit better on a Vive, because I think the Vive controllers actually have like a touchpad, if I recall. So I imagine it works a little bit better on that. But yeah, so that's how that works. I'm also going to show you how to do this in C++ here in a second. I'm not going to show how to do like the rotation and everything. I'm going to keep it pretty simple for the most part. So yeah. But let me go and show you how the blueprint functions. So if we go ahead and jump into here. So it's essentially going to be the same as how the C++, or it'll be similar to, I guess I should say. It won't be exactly the same. So if we actually go ahead and jump into the motion controller pawn, this is actually where it all starts. So motion controller pawn, if we jump down here, we have execute teleportation right here. And this, I believe, should be called, yep, here we go. So these are actually bindings that are already set up. And we'll set this up in a second in C++. But anyways, so it will essentially activate the teleporter on either the left or right hand, depending on which one is actually being pressed. You can actually see it also disables the one on the opposite hand in case it's running. So yeah, the motion controller pawn is honestly the simplest part of the whole thing. The most difficult part out of this whole thing is right here. This is where it'll actually fade the camera, and then teleport, and then it'll go, and then it'll unfade. And then if we go into motion controller, this is where you get a lot more stuff here. Here we go. The teleportation arc. This is something I will show you how to do here in a second. It's certainly not the easiest thing to do. Essentially, what we do is we create a series of meshes to create what looks like to create an arc, essentially. And it'll basically reset every. It'll constantly create it, destroy it, create it, destroy it, in order to make it look like it's just one arc that's moving around. So that's how all that works. So I'm going to go ahead. If you want to look at this code even further, right here is where it actually creates the arc, because we use spline components for that. And then, yeah. I'm gonna go and jump over into C++ code. If you want to look at this even further, again, the motion controller pawn, the BP motion controller, are what you're gonna want to look at. But I'm gonna go and jump over into C++, and we'll go and start implementing this. All right, so here we are. I'm in the playerpawn.cpp. Actually, let me go and jump over here to the header, because there's gonna be some things we want to actually create real quick. We are gonna want to create a couple functions. Teleport. Hold on. Void teleport left. Void teleport right. And I believe we also need to create one for when it's released as well, because we actually need to know when it's time to actually teleport. Left release. And we'll also go and create one for teleport right release. There we go. So we're gonna go ahead. Let me actually first create these functions real quick. I'm just gonna grab all these, just dap these on the functions real quick. So there's that. And then we're going to go and create bindings real quick. So let's go ahead and do player input component. And we're going to want bind action. So there's already a couple that are actually created, which you should have actually seen the motion controller pawn right here. It's teleport left and teleport right. So we're going to want to run our teleport left and teleport right functions when they're pressed, and then our teleport left release and our teleport right release once they are released. So I'm just going to go ahead, set this up real quick. We'll just call it teleport left. And we'll want to run one when pressed. Yes. A player pawn. Okay, and I'm just gonna go ahead, copy these real quick. All right, so there we go. We're gonna have to call some functions from the motion controller upon in a second, or from the motion controller here in a second. But I'm gonna go ahead and wait a sec. I'm gonna go ahead and create those real quick before we call them. So I was gonna jump into the header, but I forgot that there's actually quite a few things we actually have to include here. So I'm actually going to go ahead and add a whole bunch of these things in. Yeah, there's a lot of things that we need to add in for this one. First one we're gonna add in is a spline component.h. I'm also gonna add in component slash spline mesh component.h. Let's see, is there anything else we have to add? I don't believe so, at least not at the moment. I'll go and leave that at that for a second. So we're gonna go ahead and add in a couple of components here. First one we're gonna add in, if I can type right. There we go. First one we're gonna add in is a uSpline component. This will be used to create our arc, or it won't be used to actually create the arc. It'll be used to create the initial point, to initially get what our arc's gonna look like. That's the best way of phrasing it. So yeah, I do not believe there's anything else we have to add in there. We do have to add in though quite a few variables here though. Let's see, I'll go and create them protected. Hold on, not that. Jesus. Hold on. All right, so I'm sorry I'm actually jumping around here a little bit. So because I actually have some notes here on my on another display, and there's just an awful lot of things that we actually have to go through in order to actually make this all work. So I'm just kind of working on going through all this. Call this beam mesh. Actually, I think I'm gonna need to add in a static mesh included. I'll worry about that in a second. T-array uSpline mesh component spline meshes, and then we're also going to need to add god dang it. Okay, so that should be everything that we need there. I'm actually going to comment this real quick. For actually it's arc bars. There we go. That'll work. Let's see. We're also going to want to create one for drawing the arc out. I'm also going to want to create one for clearing it. I believe that's all that we need for this one. So we're going to go and jump into the CPP file next. Actually, let me go ahead and create these, and then we'll jump over into the CPP file. Go ahead, quick actions. All right. Okay, so we went ahead and so since we created this component for arc, we're gonna have to go ahead and create that real quick here in the constructor. The default subobject uSpline component text arc. To the hand mesh needs to be capital H there. Alright, so the other thing we're going to want to add in is you'll notice I created this beam mesh. What this is for is if we actually go and jump over into here, beam mesh. So beam mesh is this little thing. It's actually supposed to have a material to it. If you want, you can still add that in. I'm going to go and add in this one. This is essentially what our arc is going to look like right here. So you can go and grab that. So that way we can use that. Another thing, I'm not going to bother adding in right now. But you can if you'd like. It really wouldn't be that difficult in all honesty. Is this fat cylinder. This is actually pretty good too for teleporting around. Especially because I don't personally like that, you know, rotating the thumbstick, which is really what this little beam direction is good for, is, you know, telling you where you're going to be facing once you teleport. But this is a good alternative if you don't want to use the beacon direction. But the beam mesh is what we're going to need for actually creating the arc. So I'm going to go ahead and jump over into here. We're going to go and grab that real quick. Constructor helpers. Oh. F object finder. I'll grab a use static mesh. Call it beam. Reality slash meshes slash beam mesh. There we go. And then we'll go ahead, beam mesh. I think, didn't I put a lowercase b? I did. It's not, that wasn't intentional, but you know what? Okay. That should be it for all of our constructor. So we're going to go ahead, and we're going to go ahead and jump down here into draw arc. We're also going to need to go back to the tick function here and there. I believe there's actually a variable I actually forgot to create here. There was one. So if we go ahead, public, we're going to need a public variable. This is actually, damn it. Alright, so we're going to go and jump down to here. There's going to be a couple of things we're going to need to add here into the tick, as well as the draw and clear arc. But first, there was one variable I forgot, which is actually going to be required for this. It's going to be called teleport active. And this is actually, if we go and jump over into here, this is actually going to be what we want to call here. So if we actually go ahead, we're going to want to grab our left and right controllers for this. This one will be left controller teleport active becomes equal true, and I'm just going to copy this one for the right one as well. Just change it to right. Okay. And then we're actually going to need to do a little bit more for this one. So let's first go ahead and grab this. Set these to false. False. Okay. The other thing we're going to want to do. Actually, no, I think that should be good. I believe that's actually good. We're going to go ahead and just leave that as is for now. So if we actually go and jump over into here, so there's going to be quite a bit of stuff we actually have to do here. Alright, so let's go ahead, get this right on. So first thing we're going to want to do is, if the arc is active, which the arc is going to be this right here, then we're going to want to clear it. So clear arc. Okay, now if we have the teleport active, then we're going to want to redraw it. So essentially what this will do is on each tick, it will, if the arc is visible, it'll clear it. And then this will happen immediately after if teleport active is still true. So it'll redraw it right after that. So it'll clear the original one, draw the new one. That is, for the most part, fairly simple. Okay, so next thing we're going to do is draw our arc. But before we do that, there's actually an include that I didn't forget. And that's going to be Kismet / gameplay statics types .h. And I'll show you what this is used for here in a second. So now we're going to go and jump back down to our draw arc. First thing we're going to do is grab the arc location. Okay, and this is essentially just going to be where we start our arc at. The component location. And I spelled location wrong there, didn't I? There we go. So this is actually what we need the gameplay statics for. Gameplay statics types. So we're going to want to create an f predict projectile path params, and we'll just call it params. And we'll do f predict projectile path params 0.0f arc location, and then we're going to want to get our hand mesh's forward vector times so this is actually where we grab, where is it, right here, arc velocity. So we'll go and grab arc velocity and then 2.0f. So let me just give you a quick rundown of what this does. Essentially what this does is this is how we get our arc. So it'll essentially go from our start location, or right here where we set it to our hand mesh's location, and then we'll go and then we'll launch forward from that hand mesh. And because get forward vector is actually normalized, we'll actually be multiplying it by the velocity to actually make it go further than it actually would have normally. If you don't do this, then it's it's probably not going to go very far. So yeah, just keep that in mind. So yeah, it doesn't have to be multiplied by 900. You could multiply by more or less. You don't even need to necessarily use a variable for this if you really didn't want to. But it makes it a little bit easier to adjust, just knowing that you have to go in and just adjust a variable in order to change how far close you can go. So yeah. Next thing we're going to do is we actually have to modify a few more things with this. We'll want to set trace with collision equal to true. We'll also want to trace complex equal to false. Params.trace channel collision channel ECC world CC underscore world static. And in case you're unaware of what this does specifically, just because I think it's the most important part of all these three, is that this is actually this is what channel it'll trace on. So if you actually go into Unreal Engine, you can actually click on things, on anything in the scene. And if we actually go, where is it? Collision. We can actually see that a lot of these are probably actually set to default. This one isn't. And we can actually see there's a world static option here. So it'll actually check everything on world static and see if it can hit that. So you can see like this one will actually block. So there's 3 different stages. You have ignore, overlap, and block. Overlap will essentially go through. Ignore will obviously ignore, and block will actually stop the trace right there. There's a lot more to it than that. Than I'm really going to explain in this video, but that's essentially the easiest way of thinking about it. So yeah, and you have other channels as well. World Dynamic, Pawn, Physics Body. Some of these are default. Some of these are not. I'll put it that way. So yeah, and you can create your own as well, but that might be something I cover in a future video that covered the collision system in more detail. So yeah. Next thing we're going to want to do is we're going to want to do hit results becomes equal to u gameplay statics, which is actually something I think I forgot to add in. So that's going to be another include. So if we jump right up here to the top, it's actually another Kismet. Kismet / gameplay statics .h. Alright, so there's that. And where was I? Here we are. So if we go and jump back down here, we want to do predict projectile path get worlds params results. There we go. Okay, so there was one variable that I did actually forget. So we'll go and jump down to here. F predict projectile path results. So there we go. Everything else should be perfectly fine. So we'll go ahead, jump back over into here. Alright. Now this is where it will definitely go a little bit crazy. Alright. So first thing we're going to want to do is we're going to want to check if we actually hit something. And if we did, then we're going to want to do const f predict projectile path point data results, and we'll grab result.path data. This will essentially be the path that we want our arcs to follow. So then we're going to want to do spline points dot add result dot location. Actually, I think I forgot to add in spline points as well. And spline points result dot location e spline coordinate space world. Alright, so there was one variable, again, I forgot. I really apologize. This video is going to be all over the place just because there's so much going on for just setting up the arc. You don't necessarily need to do an arc. There are other ways that are way easier. But I'm trying to... I wanted to kind of replicate what you do in Blueprint into C++. It's just that some things don't really go over smoothly, which is why it's going to be a little bit more work. So yeah, there's all that. Spline points had to be added in right here, in case you missed that. So let's go ahead. Next thing we're going to want to do is this is the point where we actually added in. These were all the points that we're going to be, that the meshes are going to go along to create the arc. This is where you actually create the visible point of the arc. So if we go ahead and we go if arc set spline point type to results dot path data dot num -1 spline point type curve clamped. There we go. Then we're gonna want to create a for int 32 I is equal to 0, I is less than spline points dot num minus 2. I do want to say I don't really know why it's minus 2. I've looked at a lot of documentation. There is documentation that explains how to do like some of this. I've seen people put this minus 2. Nobody's actually, from what I can tell, nobody's actually been able to explain why we do minus 2 for the spline points. But yeah, I just have always found that weird. If anybody does actually know, leave a comment. I'm kind of curious as to why it's minus 2 instead of like a minus 1. I would understand if it was a minus 1. I don't understand why we have to go back 2 points though. I've just always found that weird. Yeah. So next thing we want to do is spline mesh component. Spline mesh equals new new object, not u object, and we'll want to create a spline mesh component. All right. Spline mesh register component with world. And that's actually supposed to be a lowercase b. It throws me off so much. I usually do capital for like every word in a variable. I don't know why I thought to do it with this one. Spline meshes dot add spline mesh. Okay. All right. So there we go. There's all that points. So there was quite a bit there. I kind of went quiet because I really wanted to focus on getting all this done. So here's all this. This is where we actually create our spline mesh component, which actually takes up these two right here because it also has to register with the world. We set the static mesh to the beam mesh, which is what we grabbed earlier up here in the constructor helper. If I go and jump up here, right here. So we set it so that way that's what our spline mesh component will look like. We also store it so we can destroy it later. We store it here in the spline meshes. Then we actually have to set where it starts and where it ends. The S10 E10 will actually create a arc, or would actually create like an arc for it. You can modify this if you want. You can get like weird arc effects. I remember I found quite a few sources that said that you weren't supposed to do zero vector. You were supposed to do something different. And it didn't quite work. It actually created kind of a spiral arc effect, which I thought was weird. So many people said to do it this way, and it just didn't work correctly. But yeah, besides the point. And then we just set where it starts and ends. And there we go. So there we go. We have those created. So let's see here. Next thing we're going to want to do is, that should be it for right there. Next thing we're going to want to do is actually clear the arc. So we're gonna go ahead and jump over into here real quick. All right. So let's go and see here. We're gonna want to do arc clear spline points. Spline points dot empty. Lock mesh. Set visibility to false. Wait. Okay, so not lock mesh, but everything else is fine. Alright, so next thing we're going to do is we're actually going to clear the arc. So this one is actually fairly simple. We're going to want to do arc clear spline points. Essentially, we're just going to clear everything that we had set up here in draw arc. Next thing we're going to do spline points dot empty for int 32i is equal to spline meshes dot num, because we're going to need to clear out all these as well. There we go. And then while I is greater than or equal to 0, I decrease. You probably could increase it as well. I remember I was running into some weird issues when I tried increasing it, which is why I do it this way. Just go down, because I'm going to be clearing them out as I go along. Okay, so this is where we're actually going to clear out the spline meshes here. And I'm just going to go ahead and just go down the array. While I is greater than or equal to 0, I decrease if spline meshes I, and we're going to want to destroy it. Okay, and then down here we're actually going to empty it out. Okay, there we go. There is all that. So now it should be able to draw our arc and all that. The next thing we're going to want to do is we actually want to grab a point, the point that we actually hit, which is what we had hit result for. Hit result is wherever, basically stores all the data from wherever we hit when we create our projectile path. So it has that stored in hit result. Okay, so we have all of our arc drawn out now. There's going to be one more function that I actually want to create real quick. It's going to be void teleport to location. Okay. So this one we're just going to do real quick. So we're actually going to use this real quick to actually teleport to the location that we're going to. There's a number of ways we can go about doing this. We can, if we wanted to, we could even like create a variable in here, like in the player pawn, and have it set that, detect when it's set, and have it go off. This will probably be a little bit easier though. So let's go ahead, jump up here into tick. If not teleport active, and we have a hit result. Okay, so this is going to be important. We want to make sure, what do I call it? Teleport to location. So the reason I'm checking for both of these is we want to make sure that our teleport is not active, which means that we have released the teleport button, and we also want to make sure that we do in fact have something stored in the hit result. The reason why is the way we have the projectile path set is if we actually shoot our teleport beam straight up, it actually won't hit the ground, which means that we won't have a hit result, and that can cause some funky things to happen. So we want to make sure that we do in fact have a hit result. So yeah. So what we're gonna want to do is it actually probably won't be too bad. We're gonna want to get the owner. And let's do this. We're gonna want to do get owner, and we'll want to set world location to hit results dot location, I believe is what it is, and we'll also clear the hit result as well. Hit result is equal to null. Okay, so that should be good. So yeah, we'll go and compile this and run it and see how that goes. Alright, so after last compile, I found that there was actually an issue I had made right here. This was actually from the last video. These were set to left control rather than right, which was something I was fully unaware of when I was doing this in my last video, and did not create any errors that I had noticed at the time. But I noticed after I hit compile, the left thumbstick controlled the teleportation for the right hand, and the right thumbstick did absolutely nothing. But after that, everything works fine. I went ahead and pressed compile, and if we go ahead and press play, and I let my headset go ahead and go through, which is lost its tracking. Very nice. Just set up something real quick. There we go. Alright. But yeah, now you can see I have, it's not the most attractive looking teleportation arc, but it gives you the basic of what you need in order to set up teleportation and movement in a VR game. So yeah, there y'all go. Quick little teleportation, all that works. So yeah, if you found it interesting or useful, leave a comment, like, all that fun stuff, and I will see you in the next one.